This is the BLUETTI EB3A Portable Power Station, the newest, smallest and cheapest power station produced by BLUETTI. Housing a 268 watt-hour LiPo4 battery, AC charger, 600 watt inverter and enough outlet ports for the electrified traveller. It is a seriously powerful unit in a very compact form. So I've been super excited to get my hands on and review this particular unit. My previous portable power station, the BLUETTI EB55, was one of my favourites just due to that lightweight and compact size and broad functionality. This unit here takes all of the features from that EB55 and puts them into an even smaller housing and has added a bunch of new features to make it very versatile. Now, in the interest of transparency, I will say that BLUETTI did provide this unit free of charge. However, as per all of my videos, I'm free to use, test and review this unit how I see fit in them, not being influenced by the company. Today, I'm just here to provide some information that hopefully assist you in determining whether or not a unit like this will fit your power needs. Anyway, let's get back to the video. Today we're going to talk about everything to do with the BLUETTI EB3A, including conducting some AC and DC efficiency tests, looking at the efficiency of the AC and solar inputs, charging times, parasitic draws, and the capability of the 600 watt inverter and DC ports, along with checking out some of the new features that BLUETTI have incorporated into this unit, including the multiple charge profiles, the powerlifting mode, and the remote control functions. I can say now that not everything worked as advertised, so stick around to see how I went. The EB3A measures in at 255mm long, 180mm deep and 183mm high and weighs in at 4.7 kilos. This new compact station features a 12-volt cigarette-style plug, two 12-volt barrel outlets, two USB-A ports and a 100-watt power delivery USB-C port. We have a single AC 240 volt outlet and a small LED light with input ports in the form of a 12 to 28 volt barrel connection and AC plug. This new unit features some larger buttons on the front facing panel with larger and brighter indicator lights, making it easier to see when outdoors. On top of the unit we have the BLUETTI folding handle and 15 watt wireless charging pad. So as we've come to know with BLUETTI, this unit here houses a 260 watt-hour lithium-ion phosphate battery, also known as LiPo4, which is the safest lithium chemistry, and this particular one is rated to 80% at 2,500 cycles. One of the new features on this unit is the new colour TFT display, showing us much more information relevant to the operation at a much higher brightness. This shows us the input and output displayed in watts, a center image providing the state of charge in a percentage and a graphic display along with the time remaining. This time remaining is the net result of inputs and outputs. So this means that if you're discharging, it will tell you the time until empty, and if you're charging, the time until full. We have some more information around the edge, including the AC and DC indicators, eco mode, the Hertz output, UPS mode, and faults and warnings including empty battery and overload lights. Now, in my experience, BLUETTI have always come through with the goods when stating and quoting the capabilities of their internal circuitry, but that's not going to stop us testing today. Firstly, we'll start with the DC load and efficiency tests. BLUETTI quote that we can get 10 amp from this regulated cigarette-styled output, so let's have a look. With no load, we can confirm that the 12-volt circuitry is regulated at 13.4 volt, which means that this will be perfect for powering voltage-sensitive equipment. Testing the 10 amp maximum capacity, and we see that this unit has no problems. I did find that nudging it up to 10.3 amp would result in the voltage dropping down to 3, which isn't going to be usable for most devices, so it's definitely a 10 amp maximum. I then ran a 5 amp draw from the 12 volt outlet until we achieved a total of 226 usable watt hours from this battery. This is reasonable. The industry standard is around the mid 80% efficiencies. It's probably safe to assume that the bottom 10% of this battery is protected for power reserve. The remainder is very likely due to power loss from the 24 volt down to 12 volt step down circuitry within this unit. Now, I also plugged in my dual drone battery charger to test the 100 watt power delivery port, and we see a maximum of 93 watts. Now, as we know, USB-C is becoming the future of charging, specifically fast charging, so it's good to know that this port here and the circuitry can handle that load. The 12 volt DC circuitry is also vulnerable to parasitic draw, which is the power loss experienced from the circuitry when no external load is applied. Essentially, this means the power loss experienced with the 12-volt DC outlets powered on with nothing plugged in. During my testing, I experienced just over 1% per hour power loss, achieving 5% power loss over the course of 5 hours in eco mode. And we'll get onto eco mode a little later on. So let's move on to the AC power tests. Now, the inverter inside the EB3A is quoted to have 600 watt continuous ratings, and it surges up to 1200 watts. Testing this, I had no problem in running the unit at 600 watt. I also found that the 600 watt was its absolute max, and there was a couple of occasions where this unit would cut out from overload at only 605 watts. Unfortunately, this wasn't the same story with the surges though. I could not get this inverter to peak anywhere near that 1200 watt mark. I'd load the inverter up with some accessories and then run an appliance at short intervals, and it would almost always cut out immediately. Testing this on the mains power, we note I only pulled up to 838 watts for a couple of seconds. However, on the EB3A, it would overload every time, so I'm not quite sure what's going on there. Moving on to the efficiency rating, draining the unit from full to empty, we achieved 225 watts capacity, again resulting in 84%. This is almost exactly the same as our DC test, and it's very impressive as generally AC inverters are not as efficient as DC circuits. However, this test didn't all go to plan either. The battery was completely drained as planned. However, because the battery had shut off all power to the rest of the unit, including the internal fans, it overheated. The unit, after working hard to power 500 watt continuously for almost 30 minutes, got quite warm. So when I went to charge it back up again, we got temp warnings and had no charge administered. Even when plugging AC into the unit, we can see the UPS function start up, however the fans didn't, and I believe this is because of the 0% state of charge. The exterior of the unit is only a few degrees warmer than ambient. However, the internals through the vents were warmer, reaching up to 40 degrees Celsius. I had a fan blowing air over the unit for over an hour and a half before the unit would begin accepting charge again. So this is not great at all, and it took a long time for that temperature to come down before I could use the unit again. Now, saying this, it should be able to be fixed with an internal firmware update. Having the ability to turn the fans on with the AC input plugged in, even if it's not powered from the main battery itself. So I have forwarded my results onto BLUETTI, and let's see what they have to say about it. AC inverters are generally not as efficient as DC circuits, and this is also noted when conducting the parasitic draw test on the AC outlet. I got just under 6% per hour, or 23% power loss over 4 hours. Now, while we're talking about the AC power outlet, we can check the output voltage, which sits at the 232 volt level. We can also plug in the oscilloscope and notice that the unit provides clean and predictable, pure sine wave power as advertised. I continued to monitor the power output and added a load, and we can note that the power curve is still very clean. Now, there is an exciting new feature that BLUETTI have incorporated into this unit, and they refer to it as power lifting. Power lifting has the ability to manipulate the voltage and the current to give us a higher wattage output. So as we know, volts multiplied by amperage gives us watts. So for an example, if we had an appliance at 240 volts, pulling in 2.5 amps, then we reach our 600 watt maximum. The EB3A has a 600 watt inverter, so as long as we stay under this power level, we're able to run the AC circuitry. Now, the power lifting mode has the ability to lower the voltage for higher wattage appliances in order to keep them running. But it should be noted that it's only for resistive loads, and the app will tell you this every single time you turn this system on. A resistive load is a passive two-terminal electrical component that implements an electrical resistance within a circuit. So what this means is don't be plugging in things like computers, processors, or any type of sensitive AC equipment. What it could be used to power, however, is something like this little electrical heater here. The resistive loads are the small coils within the unit that heat up and consume power within the circuit. On a normal 240 volt circuit, this heater pulls 1025 watts on low and a little under 2000 watts on high. Plugging the heater into the EB3A on standard mode, the unit overloads the AC inverter on the low setting. Switching the power lifting system on, and we see the heater continues to run, pulling roughly 362 watts. Having a look at the voltage though, and we're only using about 141 volts. We can also see that voltage taper down on the oscilloscope in real time as well. Using this function on this heater, it definitely isn't running as it should. The fan speed is slowed right down and the coils are only just heating up. The unit will only power for a short time with the heater on high before overloading, even with this setting activated. However, we know that the power station lowers the voltage all the way down to 105 volts at about 383 watts before overloading. This is a very clever feature, but how useful it would be would depend on what you plan on powering. If you had a resistive load at just over 600 watt, then it would be very helpful, but you're not going to get much usefulness out of a little heater like this, even with that setting activated. So now that we have an empty battery, it's time to start talking about the ways in which we can fill it back up again. And BLUETTI offer 3 charging methods: AC, DC, and solar. So starting with solar, and this unit here can handle up to 200 watt of solar input between the voltages of 12 and 28 volt at no more than 8.5 amp. Now, one great thing is that BLUETTI do say you can use any solar panel with this unit, providing it matches those requirements. However, that you will need a MC4 to barrel style input connector. Now, unfortunately, this particular unit does not come with this from factory, so if you want or need to charge this unit from solar, you are going to have to add one of these to your purchase list when buying the EB3A. Today we've plugged in our BLUETTI PV folding solar panel producing 25 volt and placed in mid-afternoon sun on a reasonable day. We pull in about 140 watts of power. But if we were to run 2 of the BLUETTI SP panels together in parallel, this keeps the overall voltage down to about 24.9 volt, but doubles the wattage to 400. Now the EB3A won't accept anything more than 200 watts of solar, and here we can see the unit maxes out at 188 watts in our test. Now always remember, you can overload the wattage coming into these units, but you cannot overload the voltage, so just make sure to keep it within that 12 to 28 volt mark. Now if we were to sustain 188 of solar input coming into this unit, we could charge the battery from empty to full in less than 1.5 hours. And if we just had the one PV200 panel at 140 watts, just under 2 hours. Now we can also charge this unit from DC inputs, essentially something like a 12 watt circuit like you would find in any ordinary vehicle. Now unfortunately, BLUETTI did not provide me with the cable, and it should go to note that that cable is also not included with this unit when you purchase it. However, theoretically, if we're able to input 8.5 amps from a regulated 12 volt socket, then on paper we should achieve about 110 watts of charging. Now for my research and seeing some other people test this, they are realistically getting around the 90 watt mark, so it's not too bad and means that we could charge this battery from empty to full in about 3 hours. The third and final way to charge this unit up here is through AC or mains power. And this is where BLUETTI have incorporated some new great features into the EB3A unit. Firstly, they've done away with the massive charging brick or transformer that has come with previous versions. We now get this nice and straightforward, simple 240 volt AC cable that plugs directly into the unit. Not only did that transformer on the other units take up space, but had an additional fan that ran along with the cooling fan of the power station itself, making additional noise. Now secondly, we have multiple charging modes or speeds that can be selected within the smart app. We can choose between silent, standard or turbo. Essentially what these modes do is change the rate or power input that is provided to the battery. The silent mode inputs about 104 watts, the standard about 265 watts, and the turbo all the way up to 340 watts. So at these charge rates, if you're going to be charging the battery from empty to full, you can do so in 2.5, 1 hour or 47 minutes respectively. Now in my testing using the silent mode, although we did see a much slower rate of charge, there are times when the internal cooling fans do turn on at a slow rate. So although much quieter than the other modes, still far from silent. Further, it should be noted that although we can achieve a full charge in about 47 minutes from that turbo mode, BLUETTI don't recommend this as a continuous or regular charging profile, as it can shorten the overall cycle life of those lithium battery cells. Thirdly, a new feature added to this particular unit is UPS, which stands for uninterrupted power supply. This UPS feature is an awesome new addition to this unit and really adds a whole other function to a portable power station like this one. It protects sensitive electronic equipment from dirty or unpredictable mains power. This avoids sensitive electronic equipment being shut off suddenly when mains power is cut, as it instantaneously switches from AC to battery power. I've been using a dedicated UPS system to power my internet and security system in my house for years. Not only useful for power outages, but it means that I also have access to my CCTV cameras, activate alarms and external lighting remotely. When testing the UPS system, we note the voltage when the station is plugged into mains power is at 242 volt. Disconnecting that power, this instantly changes the inverter output running to 232 volt without any delay. Now lastly, BLUETTI have also incorporated pass-through charging onto the EB3A. However, it's a little different to its previous units. BLUETTI have always supported pass-through charging, however, they've always added a caveat saying it wasn't recommended. This is because charging a battery and discharging the battery at the same time isn't best practice, and just like turbo mode, it's going to reduce the overall cycle life of those lithium cells. The EB3A works just a little bit differently. When we plug in AC power to charge the battery, it bypasses the internal inverter to power output loads. What this means, it has two great advantages. First of all, we're not going to damage the cycle life of those lithium batteries. And secondly, while we can also power external outputs, we can charge the battery at the same time. So even if we're drawing 500 to 600 watt of power through any combination of the ports, we're still able to charge the battery. I tried this out here and powered up to 600 watt of output draw through both the AC and DC circuits, and then added both a solar and an AC input. We can see that 600 watt of draw continued without issue, and we're still bringing in a 153 watts input to charge the battery. The main display is showing us that even when using this power, we still have a fully charged battery in 0.2 hours. In addition to this, this test also shows us the solar priority feature to charge the battery. Here, later in the day, we're only receiving 90 watt of solar input, and the additional power is coming from the mains. When I remove the solar, the mains power increases to fill that gap. But as soon as I replace the solar charge into the unit, we see that mains power taper down to allow for maximum solar input. We can also test the efficiency at which the AC charging circuitry runs. By installing a watt meter into our mains power and allowing the battery to charge from empty to full, we note that the unit required 347 watts to charge the 268 watt hour battery, providing an efficiency of about 77%. So now that we have the efficiency readings from both the AC charge and AC discharge inputs and outputs from this power station, we can calculate round trip efficiency. Now, round trip efficiency is calculating how many watts it takes to fully charge this battery, and then how many usable watts we can get from that out of the internal inverter. So in this instance, we're getting 347 watts to fully charge this station. And from that, we're only getting 225 usable watt hours from it. So this is equivalent to about a 65% efficiency. Now this is okay, it's definitely not the worst in the market, but it's definitely not the best. But it should be noted that the majority of the loss of efficiency is in the charging of the power station. So it isn't really going to be an issue or a detriment to you if you're planning on using this out in the bush. Now lastly, we can also charge this unit from a combination of both AC and DC power sources together for a maximum and a huge whopping 430 watt hours into the battery. Just like turbo mode, it's not recommended for continuous charging profiles, but it is going to charge this battery from 0 to 80% in 30 minutes. Now I did try this out, and we can see that we did receive that full 430 watts of power, and also, again, we can see that solar priority function working. So as with everything these days, smartphone connectivity is becoming the new norm, and BLUETTI have created an app that can monitor and change some of the settings within this EB3A remotely, as you've seen in part of this video. One advantage with BLUETTI is, however, you do not need to subscribe or create an account to connect your smartphone to this unit. Of course, if you wish to do so, you can create that account, but connecting the unit could not be simpler. Simply opening up the BLUETTI app, pressing connect, selecting the device you're looking for, and that is it. Now from the main page of this, we can monitor the inputs and outputs of the AC and DC currents at the same time and see exactly where that power is going. The only thing I noticed that was missing from this app is a time to empty your full indicator as displayed on the unit's main display. We can switch on and off and manually control the power to each of the AC and DC circuits. In the settings page, we also have the ability to control the charging mode, activate the power lifting and eco functions. In addition to activating the eco mode, we can also select how long the unit stays on for. Now the eco mode activates a unit shutdown feature, which will turn the unit off after 4 hours if it detects less than 10 watt on the AC circuits and less than 1 watt on the DC circuits. Now one huge advantage to app connectivity to a unit like this is firmware updates. As BLUETTI engineer and create more efficient and better systems, they're able to update the firmware and the way in which this unit operates to produce more efficient circuitry and potentially more usable power from these lithium batteries. Now the issues I had with the cooling fans not restarting when the AC was plugged in at 0% charge is an example of what potentially could be changed with firmware updates from BLUETTI down the track. Now one of the biggest benefits to this particular unit, the EB3A, is the cost, or I should say the value for money. BLUETTI are currently selling these for $599 in Australia, which is a very respectable price. Now it may seem a little steep, but let's put that into perspective. If you needed a 240 volt outlet in your vehicle, traditionally you would go out and buy an inverter. Now a Red Arc 700 watt inverter in Australia cost $885. A Projector 600 watt inverter retails for about $500. Now when you consider that these inverters don't include lithium ion batteries, an MPPT solar charger, an AC charger, DC ports, there's a lot missing that this includes that those don't. When you consider how much this unit includes and the power it provides, it is a very good value for money. And yes, the battery capacity may be small, but look at the size of it. It's comparable to the size of my Projector 1000 watt inverter. So this brings me on to who I think a unit like this may be suited for. And the first one is, as I mentioned, someone looking for a 240 volt output in their vehicle. This unit here represents much better value for money than just buying a standalone 600 watt inverter. It includes so many more features, it's versatile, and most importantly, it's portable. If the battery capacity isn't quite as much as you need it for, well then purchase the DC charging cable. You can plug this into your vehicle to charge it from your vehicle's battery and therefore expand the capacity to be just as large. Now the second group that this particular unit would benefit would be someone looking for a UPS or an uninterrupted power supply. Now look, if you're looking for a dedicated UPS, then there are cheaper options out on the market. However, if you're looking for a UPS and then you want a portable power station for the odd occasion, perhaps out camping or a long drive on the road, then this unit here is definitely going to fill that gap. The third group that this unit is going to be perfect for is those looking for emergency backup power in the instance of a power outage. A unit like this can power a full-size home fridge, TVs, charge your phones, your torches, and other household appliances. Albeit it may only do it for a few hours, it can be the perfect gap until a more permanent solution is arranged. Now the fourth and probably the most obvious group that a unit like this is designed for is the traveller or the camper. A unit like this is going to be perfect for powering multiple load electrical appliances for those who don't want to fork out the expensive cost of a permanently installed dual battery system. Being a portable power station provides so much more versatility and functionality over a hard-mounted system in your vehicle, particularly if you're not using power-hungry appliances. Now perhaps you're going down to the beach with a group of friends and you can't get your vehicle down to the water's edge. We can also grab out your 12 volt fridge, take this unit here, and you have cold drinks on the water's edge without vehicles present for hours on end. So in conclusion, I've been very impressed with the BLUETTI EB3A, and I have no doubt that it's going to take the lead as my new favourite portable power station. Its small, compact design and lightweight, along with the folding handle design, means that it can be packed almost anywhere in my setup. The fact I managed to incorporate the charging transformer into this, along with a 600 watt inverter and MPPT solar charger, all of these ports, and included new features like the Bluetooth connectivity, power lifting and UPS modes, sure make this a very versatile piece of equipment. Now yes, the battery capacity is small, but these new features are a reflection of what's going to be added onto BLUETTI's further power stations coming into the future. Now during the testing we did find some of the limits of this unit, and the ratings that are provided for this unit are exact. We're not getting any more out of that 600 watt inverter or any more amperage out of this 12 volt DC outlet. And we did see that this unit does get quite warm just due to its very compact size. There is a lot of circuitry going on within this unit and heat is obviously going to be an issue. But when those fans didn't start up with the AC input, that caused a bit of an issue and a 1.5 hour wait time to recharge. So let's hope we can update that with some firmware, but overall, very impressive for the size of this unit. The remote control functions through the Bluetooth app, the charging transformer that's been incorporated into the design of the unit, the quick charging or multiple charging options, UPS, the size and the weight, and the overall performance of this unit really are market leading in the industry. BLUETTI have created a very compact, very portable power station that really does perform quite well given its size and capacity. Now I'm not here to try and sell this unit to you, but hopefully today I managed to provide some information that may be useful in helping you to determine whether or not this EB3A is going to be working well for your power needs. But guys, as always, thank you very much for watching to the end. I do appreciate it, and we'll see you in the next episode. Cheers.